Welcome to this short video designed to accompany the practice quiz for the digital badge on exploring relationships in graphs. The digital badge is part of the Data Science for All seminar series designed to introduce big data and data science topics to college students with no prior programming experience. If you stumbled upon this video and want to learn more about the seminar series, please visit us at the URL listed here. When studying for the digital badge, we suggest trying the practice quiz and then clicking on the link to this video and the answer explanation after taking the quiz. Similar to all of the other materials in the seminar series, this presentation is provided under the Creative Commons Attribution Share-alike license. In this video, we will be using the Neo4j sandbox on movie recommendations. The sandboxes are made available by Neo4j and covered separately by their license. Please see the Neo4j website for the terms under which they make their system available. It is not covered by this license. The question covered in this video is based on the Neo4j sandbox for movie recommendations. If you have not created a sandbox, please see the instructions in Canvas. If you stumbled upon this video, you can also follow along by creating a free sandbox at the URL shown here. The question we are asking of the data in this video is who is the user who has reviewed the most romance movies where there was an actor and director in common. Before writing our query, we should understand what data we have in the database we are working with. To do this, run the command call db.schema.visualization. In the seminar we called the command db.schema, but Neo4j has added additional capabilities, so that command has been updated. Keep this output pane displayed. You can even click on the pin icon to keep the schema output pinned at the top of all of the output panes so you can refer back to it later. Let's think about our question a bit before we start whiteboarding it. In a prior practice video, we looked at movies by the director Alfred Hitchcock and found that Joan Fontaine was an actor in two of his movies. The movies were Rebecca and Suspicion. If these were the only two movies in the database, it would be a very small database, but the data would look similar to what is shown here. Both films have multiple actors and are in multiple genres. There is one actor and director common to both movies, Joan Fontaine and Alfred Hitchcock respectively. Likewise, there are two genres common to both movies, the mystery genre and the thriller genre. There are two users, Darlene and Sarah, who have reviewed both movies. So if this were all of our data, and our question was instead looking at users who had reviewed the most mystery movies instead of romance movies that had an actor and director in common, Darlene and Sarah would be tied at two movies each for the actor-director combo of Joan Fontaine and Alfred Hitchcock. Let's now also take a look at the paths in a tabular format. Sticking with the assumption that our database only contains these two movies, we could also look at the data in a tabular format that lists the fields from each path that match the data. Only a subset of the paths are shown here, but looking at one of the users who is tied for first place, Sarah Stewart would have one row for Joan Fontaine and Alfred Hitchcock in the movie Suspicion, and another row is a reviewer for Joan Fontaine and Alfred Hitchcock in the movie Rebecca. Looking at it this way may better highlight what the query is doing. It is taking the pattern we are submitting and finding each matching path in the database. When we display the result as a graph, all of the nodes in each matching path that are the same, such as all of the matching user nodes for Sarah, are combined into a single node. Let's now get back to our actual question and start whiteboarding it. Based on our question, we can whiteboard the path we are looking for. First, we will identify the nodes in the path. We are looking for the movies with an actor and director in common. The movies must be in the romance genre, and we want to get a count by the user who has reviewed these actor and director pairs. Based on our schema, our path contains movie, actor, director, genre, and user nodes. We have some additional information in that we are looking for movies in a specific genre, romance. And from the prior practice videos, we know that Genre nodes have a property called name that contains the name of the genre, so we add that here as a property of the genre node. We are looking for movies that have actors and directors in common, so similar to the query in a prior practice quiz video, we are looking for movies directed by a director and acted in by an actor, so we add these relationships to the whiteboard. In this question, we are looking for movies in a certain genre, so we add an in-genre relationship from the movie node to the genre node on the whiteboard. We have already set the name property on the genre node, so our query is looking for only movies in the romance genre. We are also looking for users who have reviewed romance movies with director-actor pairs. In the schema, we see that the edge for the relationship that a user reviewed a movie is called rated. So we add that relationship to the whiteboard. We now have the entire query path for our question whiteboarded, so we can start writing our query based on it. For each of the relationships shown here, we have not explicitly stated the relationship because only one type of relationship exists between these types of nodes. Before writing the query based on our whiteboard, there is one thing we should notice. The movie node has 4 relationships. In the prior practice quiz videos, each node had at most 2 relationships. Why is this important? If each node had at most 2 relationships, then it can be written as a single path. If our diagram just had actor, movie, and director nodes, we could write it as a single path like we have done before. As soon as we added a genre or user node connected to the movie node, we need to add at least one additional path. How many paths do we need now? We are going to write our query as 3 paths. The first path, similar to what we've done before, will go from actor through movie and include the director node. We'll then add a second path that goes from the movie to the genre node, and then we'll add a third path that goes from the user to the movie node. The second and third paths could be combined. Similar to the first path, we could have a second path that goes from the user to the movie node and then over to the genre node. Let's start by adding the actor, movie, director path. Each of the nodes is represented as a pair of parentheses with a variable name and a node type separated by a colon. For this query, each of the 3 nodes needs a variable name. The movie node needs a variable name because we are going to count the movies. The actor and director nodes need variable names because when we count the movies, we want to count them for each actor-director pair, so we will need to be able to get the name properties from both the actor and director nodes. As in the prior videos, since acted in is the only type of relationship between actor and movie nodes, and directed is the only type of relationship between director and movie nodes, we're going to omit explicitly stating the relationship types in our query. Since every cipher query starts with a match clause, we will add the match clause at the start of our first path. In the past, we have included path variables, and if you wanted to, you could include p1 equals before the start of the first path in the query to give it the variable name p1. But we will be returning properties of the nodes and counts of the nodes in a tabular format and not the paths themselves, so we don't really need variable names for the paths. Next, we are going to add the path from the movie node to the genre node. Before we add another path, keep in mind that the match clause specifies a comma-separated list of paths, so at the end of the first line, we need to add a comma to indicate we are starting a new path. We could then add the additional paths on the same line, but to make the query more readable, we are going to put each path on a separate line. After adding the comma, press the Shift and Enter keys to make this a multi-line query. Based on the schema, the only relationship between movie and genre nodes is the in-genre relationship, which points from a movie node to the genre node, so we will add that as our second path. Since this is the only possible type of relationship that it could occur between these 2 types of nodes, we will again omit the relationship type from the query. In this path, we don't specify the node type for the movie node, but instead, we use its variable as declared in the first path. The reason is that we are not saying it's a path from any movie node, but a path from the movie node identified in the first path. If you look at our diagram on the whiteboard, that's what we are saying. We are saying that the movie the actor acted in and the director directed must be in the romance genre. For the genre node, we do not need to include a variable name since we are never going to be referencing this node anywhere, neither in another path or in the return clause. However, we do want to specify the type of the node, so we include the colon before the genre type. Without the colon, Neo4j would interpret genre as being a variable name and not a node type. Since we want to specify a value for the name property of the genre, we include the property name and value within a set of curly braces as we have done before, and separate the property name and the value by a colon. Next, we are going to add the path from the user node to the movie node. As we did at the end of the first path, we need to add a comma at the end of the second line to indicate we are starting a new path. We want to identify those users who have reviewed the movie identified by the node with the variable name m, and based on a schema, this relationship is called rated and points from the user node towards the movie node. Since again it is the only relationship type in the data between user and movie nodes, we will omit the relationship type from the query. Since we want to identify the user who has reviewed the most romance movies between actor-director pairs, we will be using the user node's name property in our return clause. So we need to assign the user node a variable name. We will call it u. At the end of the second path, the relationship is to the specific movie node that was identified in the first and second path. So we just use the variable name m, which was already created in the first path, to identify the movie node. This concludes writing the query we want to match as illustrated in the whiteboard. So now we need to identify what do we want back and add the return clause. Since there are no additional paths in the match clause, there is no need for a comma at the end of the third line. In our question, we say that we want the users who has reviewed the most romance movies that meet our other criteria as far as actor-director pairs. So we need to return a property of the user that identifies them. Looking at a user node by selecting the node in the database information panel, we're running the command call db.schema.nodeTypeProperties. We will see that user node has two properties, name and user ID. Which should we use? The user ID is likely to be unique, but not very human readable. On the other hand, names are more human readable, but may not be unique. Since we are going to get a count of the movie nodes matching the other criteria, we are going to be aggregating rows. So if we aggregate just on name, users with the same name will be aggregated together, which we don't want. To address this issue, we will include both the name and user ID properties from the user node in the return clause. Next, we need to consider the actor and director pairs before we count how many movies they were in together. Think back to the Joan Fontaine and Alfred Hitchcock example at the start of this video. In that example, there were two movies, Suspicion and Rebecca. Joan Fontaine acted in both, and Alfred Hitchcock directed both. There were two users, Darlene and Sarah, who had reviewed both movies. If that were all of our data, we would want a row in our result with Darlene's name, her user ID, Joan Fontaine as the actor, Alfred Hitchcock as the director, and the value 2 for the number of times Darlene reviewed movies with this particular actor-director pair. There would be a similar row for Sarah, and then additional rows for the other users who reviewed one of the movies, and additional rows for Darlene and Sarah reviewing a single movie, Suspicion or Rebecca, for Alfred Hitchcock and each of the other actors in their respective movies. In order to get the counts for each actor-director pair for each user, we will include the name properties for the actor and director nodes in the return clause. If the actor or director nodes had other identifying fields, such as we had a user ID for the user, we would include those fields too, but they do not. So the name is the best we can do and hope that there are not multiple Paul Newmans starring in movies. For each actor-director pair a user has reviewed, we want to count of the number of movies they have reviewed with that specific actor-director pair, so the last addition to our return clause is the aggregate function count with the variable m for the movie variable we used in our 3 paths, and that's enclosed in a set of parentheses. Here we also have given the count of m an alias that will be used in the column heading of the output, and also in the order by clause we will add to finish our query. Since most movies have multiple actors, and some have multiple directors, even if a user only reviewed one movie, they would have a row in the results for each actor in that movie along with the director of that movie. Think of the example we were looking at earlier. The movie Rebecca has 4 actor nodes. So even if a user only reviewed that movie, there would be 4 rows in our results for that user. 1 row for each actor paired with the director Alfred Hitchcock. For this reason, our result will have tens of thousands of rows. We don't want to scroll through all of those rows, so we are going to add an order by clause that will sort the results in descending order based on the movie count. Although each user will have multiple rows in the result, the user who has reviewed the most movies with the same actor-director pair will bubble up to the top of the list. Let's run this query. The query result has 2 rows at the top, which both have a count of 4 movies. However, both rows are for the same user, Darlene Garcia, but for different director-actor pairs. The first pair is for actor Katharine Hepburn with director George Cukor, and the second pair is for actor Mia Farrow with director Woody Allen. Since our question was the user who reviewed the most movies with the same actor-director pair, and not specifically which pair it was, we can answer our question since Darlene is the user we are looking for. That concludes writing and running the query to answer our question. By whiteboarding our question first, it was easier to write our query containing multiple query paths.